orbital period is same as rotation period, so it's approximately 27 days as well. Another thing I want to introduce is lunar libration. Lunar libration refers to the wagging and wavering of the moon. What this means is that, with reference to the observer, the moon appears to be shifting around, as you can see over here. So we're not always looking at the same surface of the moon completely. This wagging and wavering of the moon occurs due to three things. The eccentricity of the moon's orbit, because as you know, any orbiting astronomical body will never orbit in a perfect circle. It's always an elliptical orbit. The second factor is the inclination of the moon's rotational plane relative to its orbit around the Earth. And the last factor is small daily oscillations due to Earth's rotation. Now what does this mean? Sounds very vague, doesn't it? Let's say you are looking at the moon. In the morning, you'll be on this side of the Earth, looking down this path towards the moon. Assuming the moon is stationary, as the Earth rotates, at night you'll be on the opposite side of the Earth, looking down a different path. You realize that you are looking at the moon from two different angles. And this is what I mean by the small daily oscillation. How these actually contribute to lunar libration, I shan't go too deep into it because some of you might fall asleep or don't understand. But if you want, you can check out Wikipedia, I guess. So, based on lunar libration, we see up to 59% of the moon's surface. It would otherwise be 50% if my understanding of basic geometry is not wrong. So, let's talk a bit about lunar landscape. But before that, let me catch my breath. Okay, good to go. Anyways, the lunar landscape. So there are three general landscapes. First is the highlands, which are the elevated regions of the moon. As you can see over here, these whitish regions, they are made of igneous silicate material, which are highly reflective and therefore reflect a lot of light from the sun. They appear brighter and brighter to us. Then we have Maria. Maria is plural for mare. Mare means Latin, means sea in Latin. Why sea? These patches on the moon, people of old thought they were seas because they didn't know any better. So they called it Maria. But actually, they are basaltic lava that has cooled over time. Because in the past, the moon was geologically active. And these basaltic lava are less reflective and therefore they appear darker to us. And lastly, impact craters. Impact craters are formed when meteors and asteroids, who haven't stopped last week, crash into the surface of the moon, forming depression. But enough about its surface features. Let's talk about the color. What's the color of the moon you see most of the time?
White.
Thank you. If you say anything else, I would be quite surprised. But in actual fact, the moon is not completely white. The color of the moon is based on its mineral composition on the surface. So, regions that are slightly reddish have higher concentrations of iron oxide. Regions that are slightly bluish and darker have higher concentrations of titanium dioxide. Oh man, I'm talking about my words today. So, do you know that the Apollo missions, Apollo astronauts were nearing the moon? They actually pointed out to Houston. Houston, we have a problem. Apparently, the moon is not completely white. They indicated that the moon had a reddish tint about it. So that's one fun fact for you. Next, let's talk about some moon formation theories. There are a few moon formation theories, and there are theories because we don't know the actual reason why it came about. The first and most simplistic theory is the capture theory. Capture theory basically suggests that wandering bodies are captured by the gravitational field of an astronomical body. This is also one of the suspected reasons that Jupiter has so many moons is because it's so massive, so large, that its gravitational field is so significant that it's able to capture a lot of asteroids from the asteroid belt. Next, we have the co-accretion theory. The co-accretion theory is a slightly more complex theory. What it suggests is that as the Earth is forming, a accreting matter in the protoplanetary disk, which is basically just dust and gas. Planetesimals, which are strange rocks, crash into this proto-Earth, sending debris flying around it. This debris later coalesces to form the moon. Once again, I'm not going to go too deep into it because this is a family-friendly topic. I don't want you to fall asleep. And the last and the most widely accepted hypothesis is the giant impact hypothesis. It suggests that a large Mars-sized object crashes into the Earth while it's still forming. This throws debris into orbit around the Earth, which later coalesces to form the moon as well. In fact, a very nice name has been given to this Mars-sized object. It is called THEA, I guess. It's called THEA. I don't know why it's called THEA, it's just the case. So enough about our moon. Let's talk about other moons. Phobos and Deimos are the only two natural satellites orbiting Mars. They were founded in 1977 by Asa Paul, and actually, the surface material of Phobos and Deimos shares similarities to asteroids from the asteroid belt. And if you take a look at their sizes, they are very, very small. 27 by 22 by 18, that would be Phobos over there, the last one. Deimos is 15 by 12 by 11, the smaller one. So the fact that they are small, and the fact that their surface material is commonly associated with asteroids, this lends credit to one of the theories of moon formation that I mentioned earlier. Would you like to guess that formation theory? Really? What's the theory? Yes, that's the question. We all listening. Yes. No.
Asteroid capture.
Yes, the capture theory. Okay, later one of the questions I asked, maybe I treat on why you can actually answer it. So, did you know that the name of Phobos and Deimos were actually from Greek gods? Mars is the Roman god of war. The counterpart to Mars is Ares. Ares and Aphrodite are together, and they have two sons, Phobos and Deimos. Phobos is the representation of fear, Deimos the representation of panic, and that is the background information of their names. Moving on, we have Ganymede. Ganymede is one of the 4 Galilean moons of Jupiter. It is also the largest and most massive moon in our solar system. Ganymede is the only known moon to have a magnetic field because it is very complex in material. As you can see here, it has a molten core of more or less iron, to simply state it. There is convection currents in this core, which results in a magnetic field around Ganymede. And Ganymede is suspected to have a subsurface ocean of salt water. But how do scientists know that there is a subsurface ocean? I mean, the surface is solid, right? Solid rock, solid ice. It's not as if you can look through the surface and tell that there is any water there. Well, scientists found evidence using the Hubble Space Telescope. They observed the aurorae on Ganymede. Any astronomical body that has an aurora will have aurorae due to interaction with the solar wind. This aurora will rock back and forth up the latitude of Ganymede. But the observed aurora actually rock back and forth to a lesser degree than the theoretical value that it would be if Ganymede was a completely solid body. So, scientists realized something is interfering with this magnetosphere. Something is running counter to it. And they hypothesized that that would be the salt water of the subsurface ocean. And this is the strongest evidence we have of the subsurface ocean. Moving on. Sorry, I clicked this one. Yes. Moving on, we have Io. Io is also one of the 4 Galilean moons of Jupiter. And Io is the most geologically active moon in the entire solar system. Let's do some deductive reasoning, shall we? May I have a volunteer? What should you call it? There's a koi right downstairs. Then I have to call someone. Last chance, volunteer. Okay, since Ivy is pointing her out. So, now we're going to deduce why is IO so vibrantly colored. What geological features does IO have a lot of? What produces that? What produces that? Yes, volcano. IO has a we're not done yet. IO has a lot of volcanoes. What chemical compound or element is related to volcanoes? Yes, sulfur. What color is sulfur? Yellow, yes. What color is iron? Congratulations. Iron is yellow because it has a lot of volcanoes and its surface is coated with electrodes and compounds of sulfur. Let's play another game, shall we? Guess the mean surface temperature of iron. How about you, handsome young gentleman? Would you like to guess the mean surface temperature of iron? 100 degrees? Okay, interesting. How about you, beautiful young lady? What's the mean surface temperature of iron? The number, please. 200 degrees Celsius. Okay. How about you, average looking guy? 201 degrees Celsius. Okay. Actually, IO is very, very cold. The mean surface temperature of IO is negative 130 degrees Celsius. What gives? Why is it so cold? Because IO, well, a very simple response is that IO does not have a significant atmosphere, therefore is unable to catch heat very well. But even though IO is so cold, its lava is still very, very hot. So if you're going to go there and you're going to go touch the lava, you're going to die. But if you stand a few meters away from the lava, you'll still die because there's no atmosphere and it is negative 150 degrees Celsius. So the fact that it's both hot and cold at the same time then causes people to refer to it as the celestial body of fire and ice. Very cool, isn't it? I think so too. Another thing I want to introduce is orbital resonance. As you can see, Io orbits Jupiter 1.8 days. Europa orbits Jupiter 1.6 days. Ganymede orbits Jupiter in 7.2 days. Using my basic understanding of math, I realized that they are multiples of one another. And that is basically what orbital resonance is. Their orbits are kind of related by multiples of one another. Very simplified explanation. Next, we have Titan. Titan is the largest moon of Saturn. But what's this? Why am I showing you a picture of a ping pong ball? True, Titan does look like a ping pong ball, but it's because it has a very, very thick atmosphere. And in this thick atmosphere, nitrogen and methane interact to form an orange haze. This orange haze blocking our view of the surface. But scientists have concluded that there is surface defect on Titan. How do they know? Well, they didn't use the Hubble Space Telescope. This time, in 2005, they landed the Huygens probe on Titan. As you can see, as the Huygens probe was descending to Titan, it captured this image. It actually has a lot of geological formations similar to our Earth. So there's mountainous regions, plains, river deltas. Okay. The only difference is that Titan is negative 180 degrees Celsius. So what would be water is actually liquid ethane and liquid methane. So it also has its own, what do you call that? Water system? Water cycle? Yes, but in the form of ethane and methane. So that's one interesting thing about Titan. Next up, we have shower. Charon is the largest moon of Pluto. Charon is made mostly of rock and ice, and it is actually so large compared to Pluto that the two orbit common center of gravity. Then center of gravity is called the very center. As you can see here, Charon does not appear to orbit Pluto, but Pluto sort of orbits a point in the center as well. And Charon and Pluto can be likened to lovers, similar to the Earth and the Moon. Except the love between Charon and Pluto is mutual because they look at each other all the time. So Charon and Pluto are mutually tidally locked to one another. This means that the same surface of Charon and the same surface of Pluto are constantly facing each other. So this lends credit to the giant impact hypothesis. So scientists believe, or rather, they think that Charon was formed similar to how our Earth was formed, because of conservation of angular momentum and stuff like that when it collides. Once again, I don't want to go too deep into that. Oh, but it appears that is the end of the talk. So I've gone through some of the more unique moons of the solar system, and unfortunately, we don't have all the time in the world to go through each and every single one of them one by one. But if you like listening to me talk, I can give you my phone number. Our solar system has many moons, and each one of them represents a vibrant new world that scientists may not have a complete understanding of yet. And hopefully through this talk, I opened your eyes to some more unique moons. Of course, there were some that I did not go through, such as Europa or Umbra, whatever. But this is just an introduction, and thank you for listening, and clear skies. So now, I prepared a Kahoot quiz for everybody. So take out your phone and sign up for the quiz if you want to. Yes, it's free. Hey, I don't see you bring out your phone.
Yeah. Link or what? Or do I have to log in?
You need to log into the NUS Astro.
Or how to log in?
Just go Kahoot.
Okay, Oh no. I don't know what happened.
People not bad.
Why is this window capture but the screen is still grey? Oh, okay. Let me bring the screen down.
Okay, anyone else new joining? No one ready, huh? Okay, then we shall just start then.
Supposed to have music, I don't know why it's supposed to have, it's all enabled.
After drawing on your
No, it's also.
Congratulations, Titan is the largest moon of Saturn. Unfortunately, this is a factual recall question, and if I said this for this, the NPC will kill me. Moving on. Oh, why? Good job. Who's that one person? Hey, raise the hand now. Yes, Io doesn't have magnetosphere. The only moon that has magnetosphere is Ganymede. A bit of an inside joke. Oh. Oh, you think outgoing but not too attentive. Looks like the consensus is that NPZ is the most eccentric. Congratulations to Ayo, Meep, and Cute Girl. Oh, and Tammy and Quentin are the runners. Thank you all for participating. That's the end of my part. So now we are new box highlights by content.
Can you send the slides to me through Tele? Oh, yeah. They don't use this. Huh? Yeah, not use this. Never mind, just be careful here. Let me check the hold on. Same thing, okay. Hold on. Wait. Let me check. Wait, is this YouTube? Yeah. Accessible with display tool, which is like display by showing. Is it okay with it if YouTube uses for that?
Yeah, sure. Yeah. Radiator. There's no way for me to check. So, here and then see does it work. Wait about 1 minute. See try clicking. Try clicking. Sorry? Is it working or? I guess you have to do some it. Everything. Stay on this slide. Stay on this slide. Go to the second slide. And wait here. Wait, can you? Yeah, but the live stream will only see the title screen. I don't know. You got no speakers on that. You got no speakers on that. How about like that? I present this screen and then like just present from here.
Oh, sure, I guess.
Yeah.
No.
Just only work around the thing.
Cannot.
Increase the book. Maybe closer to the Oh wait. Then they won't see the screen. Shit. Screen capture. Oh, the second display stop. Oh my god. Everything
Wait, I know you just use the same settings. Is it?
The setting just now was use the camera to capture the screen. Here we go now. There we are. Okay. Yeah.
Wait, I won't miss.
You can just stand there and power on it. Like Nicholas just now. Just stand there. Yeah. Okay. Can you just change it if you want?
Hmm? Yeah, that's the. Okay, I guess I can start. Okay, guys, so I'm starting. So sorry about the technical difficulties, but now let's start. So, unlike Nicholas, I'll keep it short and sweet so we can all go stargazing later. So, alright. So, so what's up in the sky tonight? So, first off, like what you might see later would be Mars and Uranus. So Mars and Uranus are actually having a conjunction now. So they will appear to be close to each other than any other time. So later on, you can see Mars easily with the naked eye, like as a small red dot. But to spot Uranus, you will need to see using a telescope. So they will both be located in the constellation Aries. So where do you find it later on? They will be overhead to the northwest and spot the reddish orange star nearby. Yeah. So another prominent constellation which you could be seen later on will be Orion. So Orion is named after a hunter in Greek mythology. It will be visible overhead towards the east before moving towards the west. So this is how Orion will look like. So his head will be like over here. Then these two are like his shoulders, and then these three stars in a row are his belt. Then these two over here are his legs. Oh, we can't see. Oh no. Oh. Oh, okay. So his head will be here, his shoulders are here, and these three stars in a row are his belt, and his legs are like here, and these stars over here are his shield, and his left arm is here, his right arm is here, and yeah, his sword is here. So the three stars in the middle are actually an asterism. So they consist of Mitaka, El Niham, and El Nintak. So might anyone want to guess what is an asterism? Big Tan. Pick a number from 1 to 20.
1, 2.
Okay, so 1, 2, you. What might be an asterism? What? 7 plus? Yeah, I guess you're correct. Yeah. So an asterism is actually just a pattern of stars, but they are not formal constellations. So within Orion, you could also see the Orion Nebula, which is a quite famous nebula. They are located in the middle of the trapezium below Orion's belt, but when you look through the telescope, it won't look like this. It will look more like a black and white cloud. Yeah. So another star which you could be seen is Sirius, which is located in the constellation Canis Major. Interesting fact is that it is a binary star system composing of Sirius A and B, which are orbiting each other. It's actually the brightest star in the night sky, so it could be seen with the naked eye easily. It will be visible towards the east before moving to the west. Another asterism which could be seen is the winter triangle, which is formed from the three brightest stars in the winter sky, which are Sirius, Procyon, and Betelgeuse. So yeah, that's something you could see later on as well. And the moon will also be rising later in the night from the east, and it will be in a stage called waning gibbous, which is this one here. Yeah. Okay. Yeah. Okay, I'm done. That's it. So we can all go stargazing. Bye-bye.
Well, things are done with the call. The sky is somewhat clear tonight, so we're going to the roof of YH for stargazing. So OT, they can go up right now because they already set up. Or you can chill here for a while. Aircon is very nice as well. Yes. You want to have a touch of the roof, right? Okay. See you all there.